Hi students, today we discuss about the remaining important questions in normal distribution. Mainly remaining three important questions are there. One is recurrence relation for the moments of normal distribution. Another two are limiting cases of binomial and Poisson distribution. First, observe the recurrence relation for the moments of normal distribution. Here we consider the PDF of normal distribution. F of x is 1 by sigma rho 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. So here recurrence relation for the moments. What is the recurrence relation? First of all, the recurrence relation is a relation which consists two continuous areas. In the probabilities, there is consider two continuous probabilities, but here are the moments. That's why you should establish the relationship between two continuous moments. Yeah, in normal distribution, especially moments in the sense central moments. That's why better to do one thing here. First, you should find the mu 2n. Then, based on that mu 2n, find the another distribution like mu 2n minus 2. So mu 2n by mu 2n minus 2 relation find. So it gives mu 2n equal to something into mu 2n minus 1 or minus 2, sorry. So put n equal to 1, 2, 3, 4 like that. There will get the different moments in terms of another moment. So that's why first find mu 2n. You know very well this is the central moment. Mu 2n in the sense expectation of x minus mu power 2n. Integral minus infinity to infinity x minus mu power 2n into f of x dx. What is f of x? Substitute here. So you know very well here is x minus mu, here is also x minus mu. That's why x minus mu by sigma considered as z, x minus mu is sigma z, dx is sigma dz. All that substitute here. Mu 2n equal to infinite minus infinity to infinity sigma z power 2n into 1 by sigma root 2 pi e power minus z square by 2 sigma dz. Sigma get cancelled. Sigma power 2n by root 2 pi is a constant. Then it is a even function. That's why integral minus infinity to infinity can be converted into 2 into integral 0 to infinity. So the remaining function z power 2n e power minus z square by 2 dz. Here z square whole square is there, whole power n is there. Here is also z square. That's why do one thing here. T considered as z square by 2. So z square is 2t, 2z dz equal to 2 dt. So dz is like that. There you consider dt by root 2t. So that here we substitute here. dz is dt by root 2t. So substitute here like this. So 2t power n e power minus t into dt by root 2t. So remaining considered as common here. T power n minus 1 by 2 in the denominator, e power minus t dt. This is of the form of gamma integral, gamma of n plus 1 by 2. Then this we consider equation 1. Same like this only consider instead of n minus 1. Once we consider n minus 1, the LHS is mu 2n minus 2 equal to 2 power n minus 1 sigma power 2n minus 2 by root pi gamma of n minus 1 by 2. Now divide these two equations and simplify it. It gives like mu 2n equal to sigma square into 2n minus 1 into mu 2n minus 2. So now put n is 1, it gives sigma square. So then put 2n like this. There you get this is the recurrence relation for the moments of normal distribution. One of the important one. Like show that normal distribution is a limiting case of Poisson distribution. Means first consider the normal distribution that can be converted into Poisson distribution here. So Poisson distribution tends to normal distribution as lambda tends to infinity. If x follows p of lambda, mx of t considered here e power lambda into e power t minus 1. Standard Poisson variate considered z is x minus expectation of x by root variance of x minus lambda by root lambda. The mgf of z is given by mz of t is expectation of e power tz, expectation of e power t into z substitute here and simplify. So it gives like mx of t by root z. So mx of t by root z, the Poisson distribution apply, e power lambda into e power t by root z minus 1, taking log on both sides. So log mz of t is log of that log x plus log y. So log x plus, sorry, here is plus log e power minus t root z root lambda plus log e power log x power y format, y log x. Log e base e is 1, log e base e1 is. So now e power x expansion consider. After simplification, mz of t is t square by 2 plus t cube by t root lambda plus and so on. Now as lambda tends to infinity, consider here. So t square by 2 like that only, t cube by infinity in the sense 1 by infinity is 0, that's why the remaining terms are also 0. So finally t square by 2. So limit lambda tends to infinity, mz of t is e power t square by 2, which is the mgf of standard normal variate. That's why Poisson distribution tends to normal distribution as lambda tends to infinity. Like that, one more limiting case is there here. Show that normal distribution is a limiting case of binomial distribution. Here is also consider MGF of binomial distribution. MGF of binomial distribution is q plus p e power t whole power n. Standard binomial variate consider. Z is x minus expectation of x by root variance of x, x minus np by root npq. The MGF of z is given by mz of t is expectation of e power tz, expectation of e power t into z substitute and simplify. So here is mx of t by root p npq. So q plus p e power t whole power n format is there. Q plus p e power t in the sense t by root npq whole power n. So e power consider. So multiply here and simplify, it gives like this. Whole power n format is there. So x plus y whole power n format consider. So q into x plus y whole power n format in the sense it's very difficult. That's why do one thing here. E power minus x expansion apply, e power x expansion apply. E power minus x in the sense so 1 minus x plus x square by 2 factorial like that. E power x in the sense all plus only. So q into e 1 minus pt by root npq plus p square t square by 2 factorial npq minus t cube p cube by 3 factorial into npq like that consider. E power x format also apply. After simplification it gives 1 plus t square by 2n plus pq into q minus pt cube by 6 into npq power 3 by 2 plus and so on. So here you should take like that, n into log x format apply. Log x for log 1 plus x format, sorry. Log 1 plus x is x minus x square by 2 plus x cube by 3 like that. So t square by 2n plus pq into q minus t cube by 6 into npq power 3 by 2 is the one term plus and so on minus x square by 2 consider. So like this there is simplify in the sense it gives t square by 2 plus pq into q minus pt cube by 6 n power 1 by 2 into pq power 3 by 2. N tends to infinity apply here. Second term is having denominator n, that's why 1 by n tends to 0. Second onwards everything is 0 only. That's why log n limit n tends to infinity log mz of t is t square by 2. So limit n tends to infinity mz of t is e power t square by 2, which is the MGF of standard normal variate. By using uniqueness theorem of MGF, binomial distribution tends to normal distribution as n tends to infinity. These three are very important. Better more focus on these three. So I hope that every concept is cleared in normal distribution. Like this, They will discuss the uniform distribution in the next session. Thank you.